You are watching video on SEE examination preparation grade 10 exam subject science. This video is going to help you to revise physics chapter light. This is part 2 of the revision. The content here is prepared on the basis of previous board exams question papers. Explanation of some important topics has been given in previously published videos. So chapter light revision part 2. Define power of accommodation. The ability of the eye to change the focal length of the eye lens so as to obtain the image at the retina is called power of accommodation. Define defect of vision. The eye which does not form the image of an object lying between the near point and the far point on the retina is said to suffer from the defect of vision. Define hypermetropia, long-sightedness. It is the defect of vision in which a person cannot see nearby objects clearly but can see distant objects clearly. Define myopia or short-sightedness. It is the defect of vision in which a person cannot see distant object clearly but can see nearby objects clearly. So in case of long-sightedness, long distance can be seen clearly, short distance cannot be seen clearly. In case of short-sightedness, short distance can be seen clearly and long distance cannot be seen clearly. You have to remember this one, do not get confused. What are optical instruments? Give two examples. The instruments in which mirrors, prisms and lenses are used are called optical instruments. Lenses are used in the instruments and these are called optical instruments. Examples: camera, eye, microscope, telescope. So eye is natural optical instrument. So camera, eye, microscope, telescope are optical instruments. Name the optical instruments which make real image and virtual image. Real image is formed by camera and human eye, and virtual image is formed by microscope and telescope. So these are the instruments, devices which make real image and virtual image. Name two liquids found in the eye. Two liquids found in the eye are aqueous humor and vitreous humor. Aqueous humor and vitreous humor. You need to remember the names. A man with long-sighted eye wants to read a book, textbook. What should be the distance between book and the lens? Give reason. A long-sighted eye can see distant object clearly but cannot see nearby objects clearly. So near point is farther than 25 centimeter because near point is defective. In order to read a textbook, the distance between the book and the eye should be more than 25 centimeter. More than 25 centimeter for a person with long sightedness, hypermetropia. Question number 30. Observe the defect of vision in the diagram and answer the following questions. So two diagrams are given side by side and similar questions follow the diagram. Okay, you need to answer these questions. We will see what are these defects. If you do this defect side by side, it will be easier for you to understand and remember. So the first question is, what kind of defect of vision is shown in the diagram? Long-sightedness or hypermetropia is shown in the diagram. Long-sightedness, hypermetropia. This is longer, so you need to remember long-sightedness. And this side it is shorter, so you need to remember short-sightedness. It is shorter, not reaching the retina, so this is short-sightedness. Okay. Short-sightedness, myopia, long-sightedness, hypermetropia. Next question is, what is the cause of the defect? Now the causes of the defect, in fact there are two causes, prominent causes. Number one cause is ciliary muscles cannot make the eye lens thick to decrease the focal length, or ciliary muscles cannot contract the eye lens to decrease the focal length. So ciliary muscles fail to contract the eye lens, okay, so that the focal length is made shorter. And in this case, ciliary muscles cannot make the eye lens thin to increase the focal length, or the ciliary muscles fail to stretch the eye lens so that the focal length is made longer. Okay, so the points are written side by side and similar language is used so that it is easy for you to remember. And the next cause of the defect is for long-sightedness, eyeball is contracted. Eyeball is contracted or due to some physical reasons, physiological reasons, eyeball is contracted, means smaller, contracted, made smaller, whereas in case of short-sightedness, eyeball is enlarged or elongated. Eyeball is enlarged or elongated. Eyeball is made longer or larger. Okay, and due to some body conditions, physiological conditions. And the next question is, what type of lens is used in the spectacle of to correct the above defect and why? So for short-sightedness also it is the same question. What type of lens is used in the spectacle to correct the above defect and why? For long-sightedness, convex lens is used. For long-sightedness, convex lens is used, and for short-sightedness, concave lens is used. Okay, so long-sightedness, convex lens is used. For short-sightedness, concave lens is used. And here the reason convex lens is used to correct the hypermetropia or long-sightedness. It is because convex lens converges light rays coming from the near point, and these light rays are again converged by the eye lens so that they meet on retina. So convex lens helps to decrease the focal length. So problem is actually focal length is longer, that is the problem. And in order to correct the problem, the lens should make focal length shorter or decrease the focal length, and that is done by convex lens. Convex lens converges light rays coming from the near point. Object is kept at the near point. These light rays are again converged by the eye lens so that they meet on retina. So convex lens helps to decrease the focal length. And for short-sightedness, concave lens is used to correct the defect of suitable focal length. Concave lens of suitable focal length should be used. Concave lens diverges away light rays coming from distant object. These light rays fall on the eye lens and gets converged to meet on the retina. So concave lens helps to increase the focal length. So in case of short-sightedness, problem is decrease in focal length. So the concave lens should increase the focal length in order to correct the defect, and concave lens of suitable focal length does so. In case of long-sightedness, convex lens of suitable focal length decreases focal length so that image is formed on the retina. Now you have to show the diagram of correction, diagram of remedy of the defect. For long-sightedness, this is the diagram, remedy of hypermetropia. Convex lens is used, and this convex lens is converging light rays coming from the object, okay, which is kept at this point, right? And these light rays are again converged by eye lens so that image is formed on the retina. So this convex lens is converging light rays so that image will be formed on the retina. Convex lens is helping to decrease the focal length and the image is formed on the retina. So in case of myopia, short-sightedness, concave lens is used. This concave lens is diverging away light rays, and these light rays are falling on eye lens, and eye lens being convex lens, it converges light rays so that the light rays will meet on retina and the image is formed at this point. Okay, so these are the remedies for hypermetropia and myopia. So you need to remember the labelings. This is N1, defective near point for hypermetropia, and this is normal near point, convex lens, eye lens and retina. These are the important parts to remember, and you should not forget to draw arrows over here. If you do not draw arrow, your diagram will not be complete. Okay, so in this case also you have to draw the diagram and draw the arrows properly. So this is the defective far point. Defective far point, actual far point is at the infinity distance. Okay, so this defective far point is made by this lens. Once the lens is used, this defective far point will be formed over here, so that the eye lens can see the object kept at this point. Okay, so this is the remedy. And for this hypermetropia, convex lens cannot see the object kept at this point, actual near point. So the convex lens shift this point towards this side in defective near point, and our eye lens can see this object because our eye lens, this eye lens is defective in this case, and it can see the object kept at the farther distance. So this is the case. Anyway, in simple language, convex lens converges the light rays and the focal length is decreased so that the image is formed on the retina. In case of myopia, concave lens diverges over light rays so that image will be formed on the retina, because concave lens decreases focal length. So this is the diagram you need to remember. Now next question is, write the differences between long-sightedness and short-sightedness. It is easy to write the points after discussing all these points. For hypermetropia, long-sightedness, first you write the definitions. These are the definitions. And next point is convex lens is used for the remedy of hypermetropia. Concave lens is used for the remedy of myopia. So you can write points in this manner. Okay, so these are the differences. Mostly you'll be asked to write 2 points in the exams. Write 2 differences between eye and camera. In eye, focal length can be changed. Okay, power of accommodation, you have learned the definition. So in camera, focal length is fixed. Focal length cannot be changed. In eye, the image formed on the retina is not permanent. Okay, in case of camera, the image formed on the film is permanent. So these are the differences between eye and camera. Write 2 rules of refraction of light through lens. The rules are as follows. An incident ray of light coming parallel and close to the principal axis after refraction passes or appears to pass through principal focus. Now you can see the diagram. This is principal axis and the light rays parallel to principal axis after refraction passing through a point which is principal focus. So after refraction, the light rays pass through principal focus. This is rule number 1. After refraction, light rays should pass through principal focus. Okay, and the next rule is, an incident ray passing through the optical center emerges without deviation after refraction. Now here you can see in this case, the light ray which is passing through the optical center directly, passing through the optical center, the center of the lens, geometrical center of the lens, it does not bend, it does not deviate, it emerges out without deviation after refraction. So these are the 2 points of refraction of light through lens. Okay, for convex lens you have to write passes. After refraction it passes through principal axis. For concave lens you have to write appears to pass through, appears to pass through, because this is the false point. And for here, construction of ray diagram part is important. Construction of ray diagram by lenses is important part. It is already done in previous video. You can check the video, SE Nepal, construction of ray diagram by convex lens and concave lens. And for the defects of vision, you can see this SE exams, defects of vision, remedy or the defects of vision chapter light. So with this we finish the revision of part 2 chapter light. So we will do numerical problems in next video.